Okay, so let's start. Today, what we're going to do is we're going to start off with, we're going to resume actually range altering questions. Okay, that's what we did in the last class. Today, inshallah, we're going to resume that. Okay, we're going to learn how to solve questions, trigonometric questions where we have to alter the range. Okay, I hope you guys remember the basic concept. Okay, so we're just going to build up on that. Okay, here we go. So, can someone summarize in simple terms, okay, without making it unnecessarily complicated? What's next after range altering questions? After this, we will do identities. Okay, so we'll do identities, and yeah, okay. With identities, we will do some equations, and then identities on and off. Okay, because identities you have multiple cases of identities. You have the proving part of identities, and then you have to sometimes solve trigonometric equations using identities. Okay. Okay, so as I was saying, can someone summarize how we approach range altering questions in simple terms? Okay.
So basically, we have to multiply the coefficient of x with our range,
Yeah.
and by that we'll get our new range. And once we have the answers through our basic method, we will just add a 360 in it until unless we reach our maximum limit of the range.
Yeah. Okay. So when we alter the range, chances are that the number of solutions will change. Okay. Maybe we get more solutions, or it's also possible that we get less solutions. Okay. So don't make these standard rules that altering the range will always lead to more solutions. It sometimes it leads to more, sometimes it leads to less solutions. Acha, let's say we have found the first set of values. Okay. How can I then find out the values in the next cycle? What do I do? Add 360. Perfect. Okay. And how can I find out the values in the cycle before that? What do I do? Subtract 360. Okay. Okay. So keeping all that in mind, let's approach range altering questions. Okay. All right. So we did two examples. Yeah. We did two examples, and then you guys solved a couple of questions. Today, inshallah, like I said, we're going to do some more complicated questions. Okay. So far, all we had to do was we had to multiply, or maybe I don't think we came across any questions where we had to divide. But today, inshallah, what we'll do is we might have to multiply, we might have to add, we might even have to subtract something to alter the range. Okay, let me show you guys what I'm talking about. Yeah, okay. Here we go. So this is a question which says solve each of the following, solve each of these equations for the given domain state. Okay, yes, let's do that. So we're still solving trigonometric equations. Okay, now I do expect you guys to have the previous concepts with you safe and sound already. Okay, I would appreciate if I don't have to go over the concepts that we have done already. Okay, I will try and brief you guys whenever a concept pops up, but not in detail. So yeah, 28th November. So, first question. Okay. The first question says, so cos x minus 30 equals to minus 0.5. All right. So, what do I do with the range? Looking at the equation that we have. Here we have x, whereas the angle that's used is x minus 30. So, how do I bring uniformity in the question? Minus 30. Perfect. Yes, so minus 30 from all sides of the inequality. So let's rewrite the question. Cos x minus 30 equals to minus 0.5. Okay, this is the original range. Now, we alter the range for which we subtract 30 from everywhere. Okay, so we turn the range into x minus 30, which means this becomes 330, which means this becomes minus 30 degrees. Okay, now we have like a weird range. Okay, why? Because it's not more than a cycle. Okay, it's less than a cycle, and we also have part of the cycle before the first cycle. Okay, so how do we deal with situations like these? I'll tell you. It's very simple. Okay, but do keep in mind that your range allows some. Your range has some negative element to it. Okay, so cos is negative. Where does that happen? Where do we have cos is negative? In the second and third quadrant. Say yeah. Okay. So let's write this down. Here's 0. Here's 90. Here's 180. Here's 270. And here's 360. Okay. Now let me get through this question first. You might have like a question straight away. Like, wait a minute. What about the minus 30? So don't worry. Let me get through this. So here we have our alpha. Okay. Let's write that down. Let's find out alpha, in fact. How will I find out alpha? For alpha, I will do cos inverse of 0.5. Again, we've gone over this multiple times, that how we find alpha, what do we watch out for when we're finding alpha. So we get alpha as 60 degrees. Okay, so here's 60 degrees, and here is 60 degrees. Okay? Acha. Then we start finding out the values of x. But remember, here when we find out the values of x, we can't do that immediately because what the equation that we're solving is cos x minus 30. So we'll start off by finding out the values of x minus 30, which we will then convert to x. So that means x minus 30 is equal to, here's the first value, which is 120 degrees. Okay. And here is the second value, which is 180 plus 60, and that's equal to 240 degrees. Now, is it a good idea to add 360 in both these values to see what value we get after one cycle or the cycle after the first one? Is that a good idea? No, it's not a good idea. Why? Because we can see that the range stops at 360. However, what we can do is, what we should do is, because the range allows us to go slightly beyond the negative side, what we should do is, we should subtract 360 to see if it falls inside the range or not. Okay, now if subtracting 360 from 240 gives a value inside the range, okay, then we'll also subtract 120 from 360 to see if it gives a value inside the range or not. If it doesn't, we'll just leave it here. Okay, so what do you suggest? 240 minus 360, what is that equal to? That's equal to minus 120. Okay, now if that is outside the range, why bother subtracting 360 from 120? Because that will be minus 240. Okay, so if let's say you do end up writing it down, let's say you end up writing down minus 120, all you got to do is just cross it out later. Also, we're not going to do 360 minus 120. We're not going to do 360 minus 120. We're going to do 120 minus 360. Okay, because how do you go a cycle after? You add 360. How do you come a cycle before one cycle? You subtract 360. So we don't go to the negative side. We tried to go to the negative side. Okay, we did try to go to the negative side. What happened? What happened? We did go towards the negative side, but what happened? The values did not fall inside the range. Okay, so now when we're giving our final answer, what do we say? We say 120 plus 30, which is 150 degrees, and 240 plus 30, which is 270 degrees. Acha, ek aur cheez, one more thing. Here's what you could have done. Remember I said for negative range, you make a separate quadrant. So if let's say you make a separate quadrant for the negative range, this is going to be 0, this is going to be minus 90, this is going to be minus 180, this is going to be minus 270, this is going to be minus 360. Yes, we're not going to use all of it. We're only going to use a part of it. But then notice what happens. If let's say we try and find out the values on the negative side in a clockwise direction, what is this going to be equal to, considering that this is 60? This is going to be equal to minus 120. Okay, and what is this going to be equal to? This is going to be minus 240. So what's wrong with that? The problem is that this is outside the range. Now the same thing that we do with the help of making a separate quadrant, we also do with the help of adding or subtracting 360. Okay, I want everyone to understand the difference over here. So it's confusing, the second graph method. Can you please, yeah, sure, I'll explain it again, okay? So I can explain it as many times as you guys want, but just make sure that you clear it, and once you clear it, you stick to it, okay? So basically, our range allows us to go on the negative side as well. That is why we're even bothering with making a separate quadrant, okay? Now, what's easier and what's not, we're not gonna debate over that, okay? If you find that easier, stick to it, okay? So no point in starting a debate, what's easy and what's not. All right. So if we are able to go on the negative side, okay, and find out the angles. Here's how we're going to do it. So this angle will be 120 degrees, and because we have gone in a clockwise direction, it's going to be minus 120. And this angle will be 240 degrees, and because we have gone in a clockwise direction, it's going to be minus 240. Okay, forget what the range is saying right now. Okay, everyone remembers how to calculate angle in a clockwise and an anti-clockwise direction. Okay, what to watch out for. So minus 120 and minus 240. All right, now let's look at the range. Remember, what we're finding out is we're finding out x minus 30. So minus 120 outside the range, minus 240 also outside the range. So that's why we're not going to consider this. Okay, now what I said earlier was that all of this we could have done by simply finding out the first set of values and then in the same values adding and subtracting 360. Okay, subtracting 360 from the same first set of values. Okay, so figure it out. I mean, work it out. What's 240 minus 360? You get minus 120. Exactly what we got here. What's 120 minus 360? You get minus 240. Okay? And do keep the sign in mind. Okay? Don't take the sign lightly. So when I say add 360, you do it in that direction only. When I say subtract 360, you do it in that way only. Okay? Not 360 minus 120, because then you'll forget which one's positive, which one's negative. Okay? So, all good? Any questions? If yes, feel free to ask. And what's our final answer, by the way? Our final answer is 150 and 270. There you go. All right, what's the confusion? Nothing to worry about. Whatever confusion you have, nothing to worry about. Tell me what the confusion is. Yes, that statement is correct. When you move to the negative side, we subtract 360. When we move forward, so when you move to the next cycle, you add 360. Okay, and when you move to the preceding cycle, you subtract 360. Okay, so if one angle, if let's say cos is equal to 0.5 at A degrees in the first cycle, okay, if let's say cos is equal to 0.5, well, when is cos equal to 0.5? I think it's 60. Yeah. So if cos is equal to 0.5 at 60 and 300, okay, यहाँ देख लो. जो हम, when we refer to the graph, like when I show you guys using the graph, I do that to explain the concept, okay, so that we can see what the standard rule is and use the standard rule, okay. So like for example over here, let's say we have cos x, okay. Here is 0, here is 360. Let's change the step to 90. Okay? Acha, hold on to your questions. Just hold on to your questions. Let's go over this. Let's change this to 1. Okay. Y equals to. Okay, now. So, in the first cycle, okay, if cos is equals to 0.5 at 60 and 300, okay, forget what we have done, listen to what I'm saying right now. If in the first cycle cos is equal to 0.5 at 60 and 300, when will cos be equal to 0.5 in the next cycle? I'll repeat my question. If cos is equal to 0.5, yeah, I'll repeat my question. If cos is equals to cos x equals to 0.5 at 60 and 300, when will the graph of cos be equal to 0.5 in the next cycle? Okay, what are the two values where cos will be equal to 0.5 in the next cycle? Okay, perfect. 420 and 660. So Maria, can you tell me how you got that answer? Plus 360. Okay, brilliant. Now, when will cos x be equal to the same values in the preceding cycle, in the cycle before the cycle, where x is negative? Very good. 60 minus 360, 300 minus 360. Okay, so that's what, minus 300 and minus 60, I believe. Yeah, if you give it in ascending order, so minus 60 and minus 300. ठीक है, खैर, that's irrelevant. So, what is the pattern here? What's the main pattern over here? Like, what's the key takeaway here? Common difference of 360. Perfect. So if you have your values of the first cycle, and maybe your range allows to go beyond the first cycle, or maybe before the first cycle, I mean the preceding cycle, what do? You add 360 and you subtract 360, depending on the question, depending on the range. Okay, that's how it works. You move, and if you want to move forward, you add 360. If you want to move backwards, you subtract 360. Yes, that's a nice way to put it, Moment. Okay, so this is the standard rule. Now coming to this question. In this question, we got our first set of values. Well, normally, the way that we get it by solving trigonometric equations. So we got 120 and 240. Okay. Now these are the values of the first cycle. Yes, always 360. Okay, 360 is what we always either add or subtract. Okay, or 2 pi if it's in radian. Okay, more about that later. Now, because a range allows us to first of all, a range doesn't allow us to go beyond the first cycle. Okay, but a range has some negative element to it. Okay, so what we're going to do is we're going to see if we have any solutions before these two values. Okay, not after, but before these two values. So what are we going to do? We're going to subtract 360 from both these values, and if that answer falls inside the acceptable range, we take. If we don't, we ignore. Okay? That is one way to do it. Another way to do it is to make a separate quadrant for the negative range from 0 to minus 360. All right. So this, what you see here, is an alternate way. Okay. This, what you see here, is an alternate way. Okay. Focus on what we're doing. Please, no irrelevant questions. Okay. Focus on what we're doing. So what is this angle going to be equal to? This angle is going to be equal to minus 120. And what is this angle going to be equal to? It's going to be minus 240. Are these two angles, minus 120 and minus 240, inside the range? No, they're not. So what do? We neglect them. We ignore them. Okay? So all right. Alternatively here. So you remember. अब कौन सा आसान है, कौन सा मुश्किल है? We're not going to sit and debate about that. Okay, I always let my students be the judge. Okay, you guys have to give the exam. You guys have to understand the concept. Not me. Trig actually makes sense. What do you mean? Acha, you mean? Okay, I'm glad you feel that way. Okay. See, trigonometric equations are in a different league altogether. Okay. And not a lot of people give the due respect that they deserve. Okay, if that makes sense to you. All right, so shall we move on to the next part? Let's do part B. Then we'll do some radian questions as well. Okay. Acha, 6 sine 2x plus 45 equals to minus 5. All right, so here's part B. 6 sine. No, wait a minute. Acha, so some people were confused. I think Jannat, you had a confusion. All good now? And who else had a confusion? Aruj, you also had a confusion. All good now? Okay, good. 6 sine 2x plus 45 equals to 5 minus 5. Oh, pura sawal dobara karna padta. All right, what's the range? The range is from 0 to 180. Okay, I have one task for you guys. Tell me the altered range. Tell me the new range. Minus 45.
Multiply by 2 and then plus 45.
Yes. Okay, remember, multiply first, then you add 45. What happens if I add 45 first and then multiply by 2? Okay, of course we get a different answer, but what's wrong with that? $45, yes, very good. 45 also gets multiplied by 2. So instead of becoming 2x plus 45, it actually becomes 2x plus 90. Okay, so if you add 45 and then you multiply by 2, so it becomes 2x plus 90. Okay. All right, so 180 into 2 plus 45. So we're looking at 405 and we're looking at 45. Okay, so now also we have like an awkward range. Okay, whenever you have to add or subtract something, you actually end up with a weird range. Okay, but nothing to worry about. Okay, all we got to do is add 360 for as long as the values are inside the range and subtract 360 for as long as the values are inside the range. Okay. Acha, before I do any of this, remember we have to write it nicely. Okay, we have to simplify it like we do with, quadratic equation and exponential equations. sine 2x plus 45 equals to minus 5 upon 6. Okay? Okay. So sine is positive. Let's find out alpha as well while we're at it. Alpha will be equal to sine inverse of 5 upon 6. Sine inverse of 5 upon 6 is equals to 56.4. 56.4 degrees. Okay? Acha. So here we go. ASTC 0, 90, 180, 270, 360. Okay, third and fourth quadrant, that is correct. Good job, pause. So here we are. 56.4. Okay, 56.4. Sine is negative. Yeah, sine is negative. Okay, here you see sine is negative. Okay, but when we're finding out alpha, we always take inverse of the positive value. Okay. Okay, now let's start finding out the actual value of x. So 2x plus 45 equals to 180 plus 56.4. So let's see what that is. That is 236.4. Okay, all good so far. Everything inside the range. And then 360 minus 56.4. So where do we stand? We stand at 303.6. All good so far. Now, because our range allows us to go slightly beyond the first cycle, what are we going to do? We're going to add 360 and see what do we get. So if I add 360 to the first value, 236.4 plus 360, we get 596.4. Now that I've written it, what do I do? Well, now that I see that it's outside the range, all I got to do is cross it out. Okay? That's it. No big deal. And then the next step, we start finding out the values of x, for which all we got to do is subtract 45, divide by 2. Okay? So 236.4 minus 45, divide by 2. So we get 95.7. Okay? And then 303.6 minus 45, divide by 2. We get 129.3. That's it. That's your answer. So, by now, I'm pretty confident that you guys are getting the hang of it. But if I'm wrong, then please go ahead. Minus 360 does not work as... Yeah, so there's no point here in there's no point in subtracting 360 from both these values. Why? What happens if I subtract 360 from both these values? What do I get? I get negative value. And we can clearly see the range has no negative element to it. Okay, so we're not even going to bother. Okay, if let's say it was like minus 100, minus 150, then where we're not sure, so then we're going to subtract. We can even write it down, and then if we later on realize it's outside the range, we can always cross it out. Okay, I want you guys to solve one part. All right, and then when we have in radians, I will, as always, do some example questions for you guys and then ask you to do some for me. Okay, radians is when things can get slightly confusing. Not because the concept is confusing, it's just because sometimes you get your answers in pi and your range is in decimal, so that is when it gets confusing. Okay, like for example, if the range is in 2 pi plus pi upon 3 and our answer is in decimal, so it's difficult for us to decide whether it's inside the range or outside the range. And there is a trick for doing that, which I'll teach you guys, so nothing to worry about. Can you scroll up? Scroll up to part A or part B? Okay, so 225 and 315 are the correct answers. Okay, I'll write them down over here, 225 and 315. And I think everyone at this point should be able to solve questions like these. Okay, I'm glad you feel that way. Okay. And this is as difficult as it gets. Okay. I mean, yes, I said earlier that with radian things can be confusing. Okay. But as far as degree is concerned, that's all there is. Acha, let's do part D. Let's see what part D says. Radian's a bit challenging, but yeah, we're gonna do 2 radian questions. Don't worry about it. Can you solve it? Okay, I was really hoping that no one's going to say that. Acha, मैं कर देता हूँ. ठीक है, I'll solve it anyway. So 2x upon 3 into 2. Divide both sides by 2 and divide by... multiply both sides by... not both sides, but like everything by 2 and divide by 3. So you have 2x upon 3, which is equal to 540 into 2 divided by 3. That's 360. Okay. and 0 divided, doesn't matter, it's going to remain 0. Okay, for as long as you're not adding or subtracting something, it's going to remain 0. Okay. Okay, so then when you write it nicely, it's going to be cos of 2x upon 3, which is equal to minus under root 3 upon 2. Okay, find out alpha, which is going to be cos inverse of under root 3 upon 2. Brilliant, that's 30. Okay, so cos is negative, which means it's going to be in the second and the third quadrant. Yeah, okay, so I'm just not drawing quadrants to save time. But in the second and the third quadrant, so you have 2 upon 3x, which is equal to, if it's in the second quadrant, it's going to be 180 minus 30. That means 150. Yes, yeah? Yeah.
Yes.
And then in the third quadrant, that's going to be 180 plus 30, so that's 210. Okay, what do you do then? You multiply both sides. I mean, you multiply all the values by 3, divide by 2. Okay, just like you would solve any other equation. Okay, take this. How would you solve this? Into 3, divide by 2. And then take 2 upon 3x, equate it to 210 into 3 divided by 2. Okay, so you'll have your final answer 225 and 315. Okay. Okay, now let's say alpha is in 150. Beta, what are the properties of alpha? Quickly open your notes where I've written the properties of alpha and tell me. Greater than 90. Isn't it the other way around? Less than 90. Always positive, always acute, and always measured from the horizontal axis. Okay? So the reason why you're getting 150 is because you're taking inverse of the negative value. Yes, I know. Okay, let's solve this question. So what is the first thing you're going to do when you look at a question like this?
Alter the range.
Alter the range. Okay. Radian mode. Okay. All right, not necessarily in that order. You can alter the range, then change your calculator in radian mode. But yeah, remember to change your calculator in radian mode. That's what I'm trying to say here. So x plus pi upon 6. So the new range is going to be pi upon 6 into 2 plus pi upon 6, which is, 2 pi plus pi upon 6, which is 13 upon 6 pi. Sir, can we do radian question in degree? Okay. So to answer your question, like, can we do it? Yes, you can. Okay, nothing wrong with that. Would I recommend it? No. Why? Because I'm pretty sure that maybe not all of you, but some of you are going to forget to give the final answer in degree. Or final answer in radian. Okay, so that's my only concern. You can do it. You can change the range to degree, and you can change pi upon 6. Everything that's in radian to degree, and then do it. But I will not recommend it. Okay? Because you can't avoid radian altogether. At some point, you have to deal with radian. So might as well learn how to deal with it. Okay? So now here's something I recommend. Okay, here's something that I always recommend, and that is just quickly find out the decimal value of the new range. Okay, like I call this like a little sneak peek. Okay, find out what 13 upon 6 pi is in decimal. How? 13 upon 6 pi. Use your calculator here and find out the decimal value. So this is approximately 6.81. Okay, and quickly find out the decimal value of this, which is pi upon 6. That's 0.524. Okay, or 0.523. This is only for you, not for the examiner. This is just for you. And why do we do this? You'll find the answer to your question in a minute. Okay, doesn't matter. Even one decimal place will also work. But to be on the safe side, take 2. But one decimal place is also good enough. All right. Like I said, this is not for the examiner. We're not going to give this as a final answer. This is only for you. And where are you going to use it? You'll find the answer to that in a minute. All right, so let's find out alpha, for which we will take cos inverse of 0.5. Remember to take the inverse of positive for alpha. So cos inverse of 0.5, which I just realized that I asked you guys to bring your calculator in radian mode, but I didn't do that myself. So cos inverse of 0.5. So yeah, that's correct. We're looking at 1 upon 3 pi. Okay. Acha. So cos is negative. Where do we see that? That happens in the second and the third quadrant. Yeah, so this is 0, this is pi upon 2, this is pi, this is 3 upon 2 pi, and this is 2 pi. Okay, so cos is negative. That means in the second and the third quadrant. All right, so what is this? This is 1 upon 3 pi. And what is this? This is also 1 upon 3 pi. Okay, so what do we do next? We start finding out the actual value of x. So x plus pi upon 6. How will I work this out? What is this going to be equal to? How will I measure this? Not measure actually.
minus 1 over 3 pi.
Pi minus 1 upon 3 pi. Okay, so let's do that. Pi minus 1 upon 3 pi. So we're looking at 2 upon 3 pi. Acha, ab this is where we have that confusion. Okay, this is where the confusion kicks in. Is 2 upon 3 pi inside the range or not? All I got to do is, so I have 2 upon 3 pi in my calculator. All I got to do is see what the decimal value of 2 upon 3 pi is. The decimal value of 2 upon 3 pi is 2.094. Okay, what do you think? Do you think that's inside the acceptable range? The decimal value, it's inside the acceptable range. Okay, why? Because we have the range in not only in terms of pi, but we have the decimal value of it as well. So it's easier for us to judge whether a certain answer is inside the range or not. Okay, so 2 upon 3 pi, acceptable. All right, then what do you think about this? For this, what we're going to do is we're going to do pi plus 1 upon 3 pi, which we get as 4 upon 3 pi. Okay. Acha, 4 upon 3 pi. Again, I want to see if this is inside the acceptable range or not. By the way, we add 2 pi and subtract 2 pi. No. Where is that coming from? Where is that coming from? Why will we add 2 pi and subtract 2 pi over here? We might add, but why will we subtract 2 pi here? When do we subtract? When you have some negative range. Okay. We might add and see if that's correct or not. Okay. So 4 upon 3 pi. The decimal value of 4 upon 3 pi, as I see it, is 4.188. What do you suggest? Inside the range or outside? Inside the range. Acha. Because a range allows us to go slightly beyond one complete cycle, we will do that. But this time, what we're going to do is we are going to add 2 pi. Okay, what are we going to do? We're going to add 2 pi. Just like how we add 360, we will add 2 pi. So if I add 2 pi in the first solution, here's what I get. 2 pi plus, let's check it out. Okay, it's not in the range. Yes, you're right, but let's do it anyway. So 2 pi plus 2 pi upon 3. So I'm looking at 8 upon 3 pi. Now at this point, it's difficult for me to judge whether 8 upon 3 pi is smaller than 13 upon 6 pi. I mean, if you're really smart, you will be able to. I mean, okay, I take that back. If you have if you remember all the decimal, if you remember the decimal values of fractions, you will be able to. Otherwise, if you're not, it's okay. No need to be sad about it. 8 upon 3 pi, if you look at the decimal value, is 8.37. 8.37. Okay, so now I can clearly see that 8.37 is greater than 6.81, so that means this is outside the range. Okay, let's see if that's correct or not, Nayan. So what we have to do is we now have to subtract pi upon 6 from both the values that we have. So 2 upon 3 minus 1 upon 6. This you can do without pi and then just write pi in the end. So just subtract the fractions. 2 upon 3 minus 1 upon 2. So that's 1 upon 2 pi. And then 4 upon 3 minus 1 upon 6 and then write pi at the end. So that's going to be 7 upon 6 pi. 1 upon 2 pi and 7 upon 6 pi. That is correct. Good job. There you go. That's your answer. So, thoughts. Somebody said earlier that wait till you get to radian. So is it really that difficult? You still feel the same way? Okay, I'm glad you feel that way. ठीक है. So the only thing we watch out for, actually not the only thing, but a couple of things we watch out for. Calculator should be in radian mode. Just write down the decimal value there and then only, so you don't have to do a lot of back and forth. So that way you can immediately decide whether an answer is inside the acceptable range or not. So yeah, that's all there is. Okay. Yes, I agree. We haven't done the hardest question yet. Okay. But
in the second in the
yeah.
part C,
Yeah. Here is
can
parts.
we just simply multiply the range by 2 upon 3 rather than of multiplying with 2 and then dividing by 3?
Yeah, of course.
Like for always.
Yeah, of course.
Okay.
You don't even have to show the step-by-step working. You just need to write down the final altered range. Okay, here we go. You guys want to give this a shot? final answer pi upon 6 and 7 upon 6 pi. Can we try part F? Yeah, that's what you guys were supposed to do. Pi upon 6 and 7 upon 6 pi. Good job, Samaria. Oh, that's what you meant. All right, no harm. So, sine x upon 2 plus, I'm solving it, okay? Pi by 6. Acha, you can't alter the range, okay. Okay. So, what do you guys suggest I do first? Do we add pi by 6, then divide by 2, or we divide by 2 first and then add pi upon 6? Divide first, then add. That's correct. Okay. So the only thing that will happen to 0 is that 0 divided by 2 will still be 0. When you add pi upon 6, it will be pi upon 6. Okay. So here's pi upon 6. And then for pi, this we have to be careful. For this we have to be careful. So divide by 2 is 2 pi plus pi upon 6. So plus pi upon 6. So we're looking at 13 upon 6 pi. Use your calculator. Use your calculator, guys. I mean, why are you being so hard on yourself? Just use your calculator when you're allowed to. Okay. 13 upon 6 pi. Let's look at the decimal value of it. 6.81. Okay. And pi upon 6. Let's see the decimal value of that. 0.52. Still didn't get it? Okay. So take 4 pi, divide it by 2, and then add pi upon 6 to it. Okay, why are we doing that to begin with? Notice what's the angle over here? It's x upon 2. That means first we divide x by 2, and then you add pi upon 6. All right. Thank you. Acha, then sine is positive. We find out alpha by taking the sine inverse of 1 upon under root 2. So we're looking at 1 upon 4 pi. So alpha is equals to 1 upon 4 pi. Now where will we find this? We will find this in the first and the second quadrant. In the first and the second quadrant. Okay. So here's the first, here's the second. Here we have 1 upon 4 pi. Here also we have 1 upon 4 pi. Sign is positive, yeah. So we're looking at x upon 2 plus pi upon 6 to be equal to 1 upon 4 pi. Let's look at the decimal value of it, 0.785, inside the range. Okay, let's put a check mark here. And then pi minus 1 upon 4 pi, that's going to be, let's see. That's 3 upon 4 pi. Let's look at the decimal value of it. 2.35 inside the range. So if I add 1 upon 4 pi to the existing value, let's see. I know we can't, but let's do it anyway. So we get 9 upon 4 pi, okay, which is 7.06. Okay, so what do? We just cross it out, no problem. Okay. And then you write down the final answer, which is, okay, I'm just going to copy the final answer. 1 upon 6 pi plus and 7 upon 6 pi. So don't freak out if you see 1 upon 6 pi written as pi upon 6. Okay, it's the same thing.
Sir,
Yeah, go ahead.
for every question like this, do we need to have like minimum 2 values for x, or like can we have one?
No, you can have one as well. Okay, there's no specific rule कि 2 होनी चाहिए 3 होनी चाहिए, 1 भी हो सकती है 2 भी हो सकती हैं 4 भी हो सकती हैं 3 भी हो सकती हैं. ठीक है, it all depends on the range. Yes, you will see that mostly you will have 2 solutions. Okay, mostly the questions are such that you will have 2 solutions, but there's no standard rule that says that. Okay, you know how when you solve a quadratic equation, mostly you get 2 answers. Okay, but sometimes you only get 1 answer, sometimes you get no answer. Okay, so that's how it is. Acha. So I had another set of questions which I was no solution is also possible. Yeah, sometimes what will happen is like you will have disguised quadratic equations in trigonometric equations. So then when you end up with 2 solutions, you will only be able to solve 1 equation further to get more answers. Okay, so it is also possible that you get no solution. Okay, so we'll get to that. Don't worry about it. Acha, sir, I have a small question of completing square. Yeah, I can totally do that. Acha, here are some questions which I initially thought of giving to you guys as homework, but I think might as well do them right now. Okay. So I'll pick the questions I want you guys to solve. I want you guys to do part A. I want you guys to definitely do part B, part D, because this has negative element in it. And then I want you guys to do so I'll just do these 3 questions. Okay. So I'll give you guys ample amount of time. Okay. Today's objective has been achieved. Today's objective was to do more range altering questions. Okay. When I expect you guys to take very long, you guys surprise me by not taking very long to understand the concept. However, opposite of it is also true. So it's okay. Things balance out in the end. So for this, I'll give you guys good 5 minutes. Okay. Now, so have a look at the answers before I solve part D. Okay. So you're actually getting 1, 2, 3, 4 solutions. Okay. See, I'm getting 49.1 and 175.9. 49.1, you might want to recheck that. It's 139.1. Okay, maybe you got the quadrant wrong. It's going to be in the first and the second quadrant. Yeah, and then you're going to add. Okay, I don't know if you have to add 360 or not. Okay, let me solve part D, then we'll do part C as well. Okay, all solutions for D are correct, but for me, but only 3. Okay, maybe there's a high chance that maybe the answer is wrong. Okay, but let's see. Let's just solve it to be sure. 3 sine 2x minus 4 equals to 2 for x is 0 to pi. Okay. Okay, like I said, maybe there's a chance that the question is wrong. 5.51 is wrong. ठीक है, अभी देख लेते हैं, nothing to worry about. Alright, so multiply both sides by, multiply everything by 2 and subtract 4. So this becomes minus 4. Okay, this will be 2 pi minus 4. Okay, and let's have a look at the decimal value of it. 2 pi minus 4. So we're looking at 2.28. Okay, this is only for us, so we can see where we have to stop. Okay, next, sine of 2x minus 4 is equals to 2 upon 3. So sine is positive. That means first and second quadrant. Let's take sine inverse of 2 upon 3 to have alpha. Acha, just realized my calculator is in degree mode. Radian, yeah. So sine inverse of 2 upon 3. So we're looking at 0.7297. So I'm afraid that we will have to round this off to 730. Okay. Or maybe let's just keep it as 7.297 since it's not the final answer. Okay. Since it's not the final answer, we'll keep it correct to 4 decimal places. And then in the end, we can round it off. Okay. So sine is positive. ASTC 0 pi upon 2 pi 3 upon 2 pi and then 2 pi. Okay. First and second quadrant, yep, that's correct. First and second quadrant. So in the first quadrant, it's going to be the same as alpha. That means 0.7297. In the second quadrant also, it's going to be the same as in the second quadrant. Let's work it out. So we have 2x minus 4, which is equal to 0.7297. Okay. And then what is this going to be equal to? This is going to be pi minus answer. Pi minus answer. So we're looking at 2.411. Acha, now here's the thing. What about 2.411? Are we going to consider it? Yes or no? $2.411. Are we going to consider it?
Yes. No.
Why are we going to consider it? I mean, is it inside the altered range?
They said it's 0.2 times more than.
Yeah, more, right? So it's outside the range. So we're not going to consider it. However, here's the thing. Pay close attention now. We will find out because a range allows us to go slightly beyond, not slightly beyond actually, a range is on the negative side as well. So what we're going to do is, we will keep this 2.411, okay, but we're not going to include it as our final answer. However, what we'll do is, we will find out the solutions in the previous cycle. Okay, so we're going to find out the solutions in the previous cycle, for which we're going to subtract 2 pi from both these values. Okay, for which we're going to subtract 2 pi from both these values. Okay, so if you guys done all of this, then your answer is probably correct. I think it's an error at the back. 0.7297 minus 2 pi. Let's work that out. So we're getting minus 5.55, which is outside the acceptable range. Okay. And then we're going to take 2.411 and from it, let's subtract 2 pi. So we're getting, this is acceptable. We're getting minus 3.872. Okay, so this is interesting. We apparently only have 2 solutions. ऐसे ही है. Okay. But sir, why will we? Okay, we will not include 2.411 as the final answer. Okay, we're using 2.411 to have the previous solution. We're using it to get the solution before the first cycle. Okay, we're not going to include it. We're not going to include it. Okay, we're only going to include these 2. Okay. So let's now find out the value of x. So minus 3.872, I have that in my calculator, plus 4 divided by 2. So we're looking at 0.064. Okay, correct to 3 decimal places. Oh, sorry, 0.0639, correct to 3 significant figures. And then 0.7297 plus 4 divided by 2. So we're looking at 2.36. Acha, 3.21 and 5.55. Yeah, this is wrong. 3.21 and 5.51 is wrong. Okay. Yeah, this is basically not the final copy that I have, so it's possible. And I'll tell you why this is wrong. Okay. Here's something interesting to note. Remember I said that the final answer should be inside the final range as well. The final answer should be inside the given range. You can clearly see that's not, because pi is 3.14. Okay. And 3.21 is greater than 3.14, which is why this is unacceptable. 5.51 obviously is also greater than pi, so that's why this is also unacceptable. So it's okay, nothing to worry about. These are the correct answers. Okay? So the answers are wrong. Doesn't happen very often. But what's the more important question is, do you guys get it, yes or no? You know what's also possible? Okay. Here's something that I just thought of. Maybe it's not the answer that's wrong, it's the question that's wrong. Maybe the question was meant to be 2 pi here. I don't know. I'm just thinking out loud. I got 3.36, but could you explain once more how you got 0.06? So we subtract, this 0.06, you add 4 in these values, divide by 2. So you add 4 in minus 3.872, divide by 2. So we're solving for x now, basically. And in this also, you add 4 and divide by 2. Okay? Yeah, go ahead. Share your completing square problem. Right? So we're going to keep it till here only now. And in the next class, inshallah, we'll do trigonometric identities. I will give you guys some homework similar to these questions. Please make sure to solve it because it's important. All right? Acha, stick around if you want me to, if you want to have a look at the question that I'm solving for Faiz. If not, then that's it. Take care, everyone. Allah Hafiz. Okay, so I'll stop here. See you guys, inshallah, on Thursday. Take care, everyone. Allah Hafiz.